Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models, they just launched dedicated CPU instances. And they also have a new object storage service to make storing data for your apps even easier. Go to pythonpodcast.com/linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, Aluxio, and Data Council. Go to pythonpodcast.com/conferences to learn more about these and other events, and take advantage of our partner discounts to save money when you register today. Your host, as usual, is Tobias Macy, and today I'm welcoming back Thomas Hatch, all the way back from episode 1, to talk about his work on the POP library and how he's using plugin-oriented programming in his work at SaltStack. So, Thomas, can you start by introducing yourself?
Yes, I can. Hello, my name is Thomas Hatch. I am the original creator of Salt, and I'm excited to be on here today to be able to talk about plugin-oriented programming, a new approach that I've got around software development. I'm also the Chief Technical Officer for SaltStack.
And do you remember how you first got introduced to Python?
Yeah, I mean, this is going back a long ways. It was back in the days when there was a bit of a debate who's going to win, right, between Python and Ruby. And I spent a lot of time looking into Ruby. I'm still really impressed by Ruby. I think that they've got a lot of really fantastic language features. But in the end, I leaned towards Python because it was it's a much richer ecosystem. And I felt that the language was a lot more pliable and a lot more usable.
And so, as you mentioned, you've been working on Salt for a number of years now, and one of the outgrowths of that is your work on this POP library. So before we get too far into that, I'm wondering if you can just start by giving your definition of how you view plugin-oriented programming and some of your thoughts on the benefits that it provides.
You bet. It's been really interesting. I feel like I almost stumbled upon the concept of turning my plugin system into a programming paradigm until about a year ago in my development, when I realized that that's kind of what I'd done. The core idea behind plugin-oriented programming is that whenever we make large-scale applications, we almost always need to make them pluggable to a certain degree, make them extremely modular. And so I thought, wouldn't it be better if we just started building things in a pluggable way? And POP allows us to build software that's not only 100% comprised of plugins, but it also allows us to create applications that are pluggable with each other, which extends the paradigm of libraries and applications into a more unified concept, where we're able to create entire plugin subsystems that define how an application is supposed to work, not only the functionality which the application exposes through a library like Medium. And so I felt that, again, that makes it so that it's a lot easier to create smaller, portable, compartmentalized units of software. It also adopts a lot of concepts from microservices, but instead of looking at things through the microservices lens, it makes it a lot easier to create compartmentalized units that run together in a single process even.
And I understand that a lot of your thinking about how this should work and some of the design features of what POP provides are influenced by the work that you've done on Salt itself, which is definitely a very extensible and plugin-oriented platform. So I'm wondering if you can talk a bit about some of the ways that Salt has influenced your thinking on how to implement plugins for software projects, and some of the ways that those thoughts and your ideas of best practices have manifested in the POP library and some of the capabilities that it provides.
Yeah. So when we come back and we look at Salt, to be honest, in the beginning, I wrote a plugin system for Salt, and I didn't think that we would use it inside of Salt anywhere near as much as we did. And at this point, I think that there are 36 plugin subsystems inside of Salt, which abstracts from a POP perspective something like 12 independent applications. And when I started working on POP, I really was looking at the plugin system inside of Salt and saying, hey, this is really useful. I want to use this in other projects without having to import all of Salt to get it. And so my first iteration was just trying to make the Salt loader standalone. But as I iterated on the idea before actually releasing it, I rewrote the POP platform numerous times. The initial release of it is actually the fifth iteration. And so not only was it heavily influenced by Salt's plugin system, but I tried to solve a lot of the problems that arose in Salt's plugin system. And again, at first I was looking at it purely from a technical problem perspective, but as I kept working on it, it became really clear that there were a lot of problems that we ran into, and that most, honestly, the vast majority of software projects, especially open source projects, run into these similar restraints and issues, mostly around maintenance of the platform. And there were a few other things from just a human perspective that I started to realize as I was working on this whole plugin oriented paradigm. And again, I mean, I've been working on the paradigm for the last maybe 3.5 years, despite only releasing it and only feeling like it was mature enough to be released a few months ago. And after literally 4 rewrites from the ground up. But one of the big things that I learned from Salt is just how much time we spend reviewing pull requests and reviewing code. So I stepped back and I started to wonder, how much time do most open source projects and most open source developers have to spend reviewing code, reviewing proposals, instead of just writing software? And I found out that I was far from alone in this problem, where the vast majority of us who create these large platforms end up having our lives consumed by reviewing contributions. Now, I don't want to say that to say that I don't like contributions or that they aren't incredibly valuable. But at the same time, I wanted my time back. And I wanted to be able to write software again instead of my time being so heavily consumed by reviewing others' code. Linus Torvalds recently said in an interview that he's not a software engineer anymore. His job is to just say no. His job is to just tell people, no, I won't let this code in. And so one of the big things that I put inside of plugin-oriented programming is the ability for someone to extend a piece of software without having to necessarily push that code upstream, so that it becomes easier for someone to write plugins and then deploy those plugins using the app merging concept inside of plugin-oriented programming. So instead of coming back and saying, hey, Tom, can you please review my code and merge it, regardless of the maturity of the code or how well it's going to be adopted or used inside of this mainline platform, it's a lot easier with plugin-oriented programming for somebody to write an app merge plugin system that literally augments the original piece of software. Then those augmentations to that original software can grow and be adopted on their own merit, just like writing an independent piece of software, which makes it a lot easier to be able to vet and verify that the software that we're looking at is something that we actually want to put into the mainline, something that we might want to support upstream. But it also puts the onus of support to any piece of software more firmly in the original author's hands, which almost universally leads to significantly better support and better maintenance of that software because of their own intent. So Salt not only influenced me technically from the perspective of saying, hey, I love plugins, I want more of these, I wish I'd made more systems inside of Salt Pluggable, it would have solved a number of problems that we've run into over the years, but also that it creates a more human, sustainable, and maintainable piece of software that means that myself and the software developers on my team are able to spend more of their time focused on engineering and less of their time focused on reviewing people's code. And at the same time, our contributors who are contributing to a POP project, since they can use app merging, they also don't need to wait on us to review their code. They can release their code independently, which again, my hope and anticipation here is that it becomes a platform that not only accelerates software development, makes high-level software development easier, but can also accelerate the development of open source software. Wow, goodness, sorry. I hope that answer wasn't grossly too verbose.
No, that was fabulous. It's definitely helpful to get a lot of the perspective of your experience of working, as you said, both technically and socially on SALT, and how that has influenced your thinking about some of the best practices in terms of how to implement software to solve both of those needs simultaneously. And I understand also that some of your motivation for creating POP as a standalone library was a way for you to explore some of these concepts independently and in isolation without having to try and factor them back into SALT itself and deal with all of the weight of everyone who is relying on SALT to be stable and reliable, and give you a way to determine whether or not you could then incorporate these ideas or possibly even the POP library itself back into SaltStack. And so I'm curious how either the technical implementation of POP or just the lessons that you've learned in the process are going to be incorporated back into SALT in some of the future releases.
So when it comes to POP inside of SALT, that's kind of a tricky concept. As I've stepped back and looked at things, the overall landscape of managing infrastructure has changed a lot. And this is still the core goal of SALT. And I love SALT, and we've done really incredible things with that platform. But as I think about it, one, POP's plugin system has fundamentally diverged from how SALT's plugin system works. It's mostly compatible. I'd say about 95% compatible with the SALT loader, but it can't drop in, replace it. Now, as we step back and we look at SALT from a POP perspective, like I was saying before, SALT is really comprised of many, many different independent projects, independent use cases. And one of the challenges that we run into from a SaltStack perspective is just letting people know how much is in there. It's incredible talking to people. We just had SaltConf last week, and it's incredible talking to people as they come back and say, wow, I'm always learning that there are more things inside of SALT. And this is one of those realizations that I had, that since I've put so much functionality into a single platform, that platform owns that functionality, but it also doesn't expose it. It also doesn't let people see that, hey, we've got beacons and reactors. I mean, almost nobody knows what thorium is inside of SALT, for instance, despite it being an incredibly powerful platform, which is used to do some amazing things. So if I step back and I look at SALT from a POP perspective, it's really easy to say, okay, if I were to re-implement SALT to run from a POP perspective, it would be broken out into countless individual applications that do highly specific things. So, for instance, Grains would be its own application. Salt Cloud would be, well, I originally thought Salt Cloud would be its own application, but I actually made the state systems language its own application called Item, and then the Salt Cloud Working Group has been working with me to actually port much of Salt Cloud's functionality directly on top of Item as these app merge features, so that each individual cloud ends up being its own project, so that it plugs directly into the language. And then that allows us to manipulate and push the language forward at a much faster rate. This implementation of the SALT state system on top of POP, called Item, already has a number of features that, given the restraints inside of the less flexible implementation of the state system inside of SALT, were just really, really difficult to get in there. But we got them inside of Item. So the state system becomes its own application. Remote execution becomes its own application. Grains becomes its own application. But then at the same time, we get to solve a lot of other problems that we run into from a SALT perspective. So inside of SALT, we ship support for all these different platforms all over the place. We test them and maintain them in the same location. But using POP, the goal here is that all of these operating system support, cloud support, API support, this huge array of just things that Salt is capable of interfacing with can be developed and tested independently, can be released independently, so that if we want to add some additional support for some new interface inside of Red Hat or new APIs inside of a cloud, all of these things from a POP perspective will be able to be released independently. And so I don't look at POP as necessarily going into the Salt code base. I look at POP as a potential for creating really the next generation of Salt, so that it's, again, something more pluggable, more pliable. It's a collection of components that are more reusable in other applications, as well as being able to solve many of the fundamental challenges that we run into in Salt, and finally also being able to take Salt and level it up, make it purely Python 3, take advantage of a lot of these new things that we have access to, like async IO, for instance. Async IO completely changes how you can write software and what you can do. Such an amazing system.
Yeah, it's definitely great to see a lot of the evolution of Salt, and I am excited to see some of these new incarnations of some of the different subsystems in their own independent implementations that can then be merged together so that you only incorporate the bits that you need rather than taking the entirety of this massive framework for everything that you might want to do in the automation space. And similar to how Linux has a lot of drivers for systems and hardware that you're never actually going to use, but it's there in the kernel anyway, Salt has sort of gone down that same road because of just sort of legacy issues and the way that software and infrastructure was managed at the time. And you incorporate all these drivers and capabilities for platforms and systems that you don't necessarily care about. So I'm definitely excited to see the future there. And then going back to POP itself, I'm wondering if you can talk through some more of the advanced patterns or paradigms that this plugin-oriented programming model allows for, and the way that you have experimented with and implemented some of these things using the POP framework.
One of the big challenges that I've got is that I'm presenting this as a programming paradigm. I kind of like to explain to people that I must be completely insane to have tried to create a programming paradigm. So I have to kind of start from the whole, what new patterns and things can be expressed by just saying, I'm not out to, destroy object-oriented programming. Much of POP has been inspired by many of the features and functionality of object-oriented programming, as well as flow programming, functional programming, et cetera, et cetera. And I wanted to be able to take a lot of the benefits from these different paradigms, but then wrap them up in such a way that, again, hopefully makes software development more human. When we look at programming paradigms in and of themselves tend to evolve out of expressing how a computer works or expressing math. And I wanted to look at this from the top level and say, what are some of these concepts that make a lot of sense to just humans naturally? What are the concepts in computers that have endured for the last 40 years I shouldn't say 40 years, but for the last 10 years, 20 years, 30 years, 40 years, that can be incorporated in such a way that can hopefully make software engineering easier, not only more powerful and more capable of just exposing a human being's idea in engineering. And so I've tried to look at POP from a top-down perspective, a human to code perspective, as opposed to a bottom-up perspective, which is what I feel most existing paradigms express. And so in doing so, I introduce a bunch of concepts inside of Salt. One of them is plugin subsystems. So when you create plugins, those plugins have to exist in a bag, right? I mean, they've got to follow some kind of pattern. And so instead of looking at software from the perspective of object-oriented programming, or I should say purely object-oriented programming, you can certainly do object-oriented programming inside of POP. But instead of looking at it from that perspective of hierarchies and inheritance and has a sort of perspectives, I instead thought, well, humans think much more in patterns. And so you can create a plugin subsystem inside of POP, and then that plugin subsystem follows a pattern. And so you're able to say, I'm gonna let's say grains, for instance. So for anyone listening who's unaware, grains is a thing inside of Salt that scans your operating system to just gather some information about that operating system. Inside of POP, you would view grains as expressing a pattern, and that pattern would be a data gathering pattern. And so any plugin that would be added to this subsystem is going to just extend how data is gathered in a collective way. Similarly, inside of Salt, we've got a plugin system that is just called modules because it was the first one. But we call it execution modules now, and it exposes a system management library. And so inside of Salt, you can make a pattern that we would call a library pattern. And so in that case, any plugin that you would put inside of this plugin subsystem would just extend that library of functions, which again is a very common situation. Another pattern, for instance, though, that we run into that we see inside of Salt is seen in the returner system. And this is a very common pattern, especially inside of Salt, where we are expressing an interface. And so this pattern looks a lot like the creation of an interface inside of object-oriented programming, where we say, look, certain functions need to be exposed to be able to fulfill the functionality of this interface. So, for instance, again, if we look at a returner in Salt, a returner is used to take information that's happening inside of the platform and send that information off to different data stores, right, databases, etc. And so it's got a collection of 6 or 7 functions that need to be implemented to create a returner. And so that interface idea is just another pattern. And so a lot of my thinking there is that, again, if we expose patterns, that's a more human way to approach programming. And it's also much more extensible. You don't need to understand an underlying abstract base class to be able to expand a system. It becomes really easy to be able to just say, hey, I'm just going to make a plugin. If it has these functions, it's going to work. And that's really all I need to know. And that's another one of those things that we learned from Salt, is that it's very, very easy for someone to extend an interface when they can look at an existing interface and say, hey, if I want to add package management support for a new operating system, here's the 6 functions I implement, and it's just going to work. It's just going to extend that system, which again, I feel based on our contributions is a really easy way to express that problem.
Yeah, being able to just copy and paste an existing implementation and then either rewrite or extend the specifics of what you care about and just keep it in your own repository and synchronize it into the system is something that I've been able to take advantage of quite a bit to manage our infrastructure at my work. So I can definitely see how that would be a powerful paradigm just for software in general of, I have this application, it doesn't quite do what I want, where right now you would usually have to fork the entire project, make the changes inline in the code base, or figure out how to extract it out and then go through the complicated process of building that interface so that you can then submit that back upstream or permanently maintain a fork of the project, versus just being able to say, I only care about re-implementing this one subsystem. I'm going to override it in this other repository and load it in. And then the person who's maintaining the core project doesn't ever have to know or care about it. I can see that that would be very powerful and a much more enjoyable way of managing software projects going forward.
Yeah, that's the goal, and it sounds like you get what I'm throwing down. So that makes me feel better. I always worry about the communication aspect.
And so, in terms of the POP library or framework itself, however you want to refer to it as, I'm wondering if you can dig into some of the ways that it's implemented and some of the other languages or libraries or ecosystems that you've looked at for inspiration as you have iterated on the design and philosophy around the development pattern and the specifics of POP itself.
Yeah. So, I mean, one of my hobbies is to play around with programming languages. I really love being able to just install and try out new languages. I honestly, now that I'm thinking about it, I haven't done any for almost a year now. But I love just sitting down and learning new languages. So my first implementation of POP that was just a fork of the Salt loader, again, was written in Python. And after I wrote it, I started looking at things and saying, I feel like there are certain limitations in Python. I'm worried about performance. I'm worried about just how to distribute software in Python, just some of those common issues that we run into when using Python. And so I stepped back and I thought, how about I try and implement this whole plugin system in different languages? And so I went back and I tried out Go and Rust. And it's not surprisingly, there's very specific challenges in implementing plugins in statically compiled languages. It's certainly possible, don't get me wrong. But there are some specific challenges there. I tried implementing it in Nim as well as OCaml. I've always been a fan of OCaml, mostly from an academic perspective. I probably wouldn't actually use OCaml. But then I stumbled across a language called Julia, and I'm a huge fan of Julia. I love what those guys are doing. I love the expression of a functional paradigm, the way that they've got it. I also love how they compile it, how they use LLVM, and how that whole statement by statement JIT compilation works. I'm probably not explaining it properly, but I mean, if anybody's interested, Julia is fantastic. I love Julia, and so I implemented this inside of Julia. And in doing so, not only did I realize that there were a number of aspects of functional programming that I felt could be really helpful, I also realized that my fundamental approach from a Salt plugin perspective had a number of limitations around how those plugins were shared and refreshed. And while working with Julia, I realized that these things could be solved. So if we come back and we look at how the Salt loader works, the Salt loader works by, well, one of the things that we've got to do when you make a plugin system is that plugin system dynamically changes the name, route, and implementation of specific functions as they are exposed relative to the underlying programming language. And so being able to change those means that in Salt, I've got to take those raw functions and then I need to embed them, basically inject them, use setAttr inside of Python to inject those raw functions directly on top of the imported module object. Now, when you put something directly on top of the imported module object inside of Python, then that manipulates the imported instance of the module inside of sys.modules, which means that if you ever want to re-import that module for any different use case, you're stuck with all of these things already manipulating that namespace. So then inside of Salt, to solve this problem, we had to come back and we had to move it so that we could import loader subsystems. Ended up in different physical locations under sysmodules, so we have multiple copies of modules that are imported, and it's kind of dirty. Whereas what I realized when working with Julia is that it would be a lot more elegant to instead make never manipulate the module layer, but make it so that module system is all abstracted on a central hub into a hierarchical namespace. I mentioned earlier that there are certain concepts in computing that have endured, despite, frankly, lots of efforts to try and get rid of them. And one of those is a hierarchical namespace, like a file system. I mean, you can't get very far in computing without understanding how a file system works. And it's such an effective way of organizing data. And so inside of POB, there's this concept called the hub. Now, the hub is the root of your application's hierarchical namespace. And so when you make a new plugin subsystem, that plugin subsystem just exists on that hub so that it is now accessible to any other piece of software that you've got inside of that process. And then that solves a problem that we had inside of the Salt loader, where if I had one plugin subsystem inside of Salt and I wanted it exposed to another plugin system, let me just say that there was some finagling that had to happen under the hood to make that work. But again, inside of POP, you put that thing on top of the hub just by saying, hey, I'm going to make a new plugin subsystem, and your entire application has access to those functions, just making that problem go away. And since we don't manipulate the module layer, everything is on the hub, then it makes it much easier for us to be able to manipulate memory namespaces directly on this hub and the hierarchical objects therein, so that allows us to be able to reuse functions for operation inside of their own kind of environments, depending on how they're invoked, which goes back into giving us the benefit of having multiple instances of objects that we get from object-oriented programming, but then adds a benefit of all of the data associated with that object being namespaced to its location, but not overly isolated, which is one of those challenges that we run into in object-oriented programming. When you're looking at things from a paradigm perspective, it's interesting to kind of say, what are some of the caveats that we run into? And one of the challenges that particularly annoys me with object-oriented programming is that you run into this thing that I call over-encapsulation. We don't even think about it because we're just so used to writing software this way. But my argument is that over-encapsulation is that once you start writing a piece of software and it starts getting big at all, you end up with an instance of an object in a file over in one part of your code. And then in another part of your code, you say, oh, I so wish I had access to that data. It's all the way over there. How am I going to get access to it? And then you can solve it with a number of ways. One, you can implement globals, like don't do that. Two, you can use language backdoors, which are almost just as ugly, right? You go into the language's internal hierarchical system and finagle it to find a backdoor to get to your object, and then that makes incredibly brittle code. Or you end up doing what most people do, which is you go up your call stack to the point where that data was originally available, and then you fork it down different call stacks. Inside of POP, you just put that data on the hub, and it exists inside of this hierarchy. It's globally accessible, but the data exists inside of a hierarchical namespace. And again, like I'm saying with file systems, hierarchical namespaces make so much sense. And so then we don't have the problems of globals, because you can look at where data is physically located and say, hey, that's not inside of this plugin subsystem's namespace, so I shouldn't manipulate it. But it's right there, right? I can make a copy of it. I can read it and use it for the instantiation of a new object or construct over here. And so I guess what I'm saying is I rethought how you expose memory to an application developer relative to hierarchical namespaces, because Julia forced me to make a hub when I was implementing it in Julia. It was just one of those, mind expanding kind of things. And so when I came back and re-implemented it again in Python, it just became a lot easier. And that's also where I started to realize, I'm expressing a paradigm, not just a really slick plugin subsystem.
And when I was reading through the documentation, one of the things that you explicitly call out is that POP itself is just a single implementation of this overarching idea, which we've been discussing, and that there's nothing that's Python specific about it. And I'm curious, one, how large the actual POP framework itself is, just in terms of code and complexity, and some of your thoughts on specifics of your implementation that wouldn't necessarily translate well or would even want to translate to different languages or runtimes.
So, that's a great question. How big is POP? I haven't run WC on that, or LOC on that for a while. Let me take a look. So if I run lines of code on POP, it says that we've got 4,218 lines of code. So it's not huge, and that's one of the goals of POP, is that these individual pieces of software, they don't have to be big. And that goes right back into maintainership. How many lines of code can you fit in your head, right? When I was originally developing Salt, I still knew where everything was until we got up to about somewhere between 50 and 70,000 lines. And I can know where everything is across 15 projects that are smaller than 10,000 lines, because they're all better compartmentalized, and I can transfer the knowledge over so much easier. I can introduce somebody to the entire POP code base in, frankly, a week of sitting down and training an employee, for instance, training an engineer. And that compactness is really valuable. Now, when it comes to other languages, one of the great things about Python is that it makes making these constructs so easy, right? Operator overloads in Python, being able to create a class that has dunder get attr and get attribute and set attribute and all this stuff is so easy. But with that said, I don't see anything that would restrict one's ability to implement this construct inside of Julia, for instance, or even inside of C++. So any language that gives you a sufficient a sufficient object-oriented interface should be expressible this way. And I mentioned earlier that it's kind of difficult to do this with compiled languages, but at the same time, when I was looking at that, I was not willing to sacrifice the idea of being able to dynamically update your pluggable software while it's running. If you sacrifice that idea, again, it becomes much more plausible in compiled languages. So I would love to see an implementation of POP in something like Go or Rust. The other thing from a language perspective is that as I've sat down and worked with front-end developers and people working in JavaScript and expressed and gotten them on board with POP, oftentimes they've come back and said, wow, this would solve a lot of the problems that we have in front-end development. Because all this data exists on top of a hierarchy. It's easy to get access to. The plugins are always accessible from any location inside of your software. It would make it so that extending something like JavaScript would be really easy. And so personally, I would love to find some time somewhere to come back and try and implement this in a few other languages. But yeah, I got a lot going on.
And one of the challenges when you're dealing with applications that are decoupled at the interface level is just defining those interfaces and ensuring that any implementation to those interfaces adheres to that contract. And I'm curious how you've approached that idea in POP as far as being able to say, this is the stub of where you can add a new plugin. These are the functions that it needs to define, or these are the data structures that it needs to be able to produce or accept, and then having a way to easily, on the other side of things, say, I'm going to write a plugin that adheres to this interface, and then be able to independently validate that it's going to work when you go ahead and incorporate it into the broader runtime or you load it into the application hub. And so I'm curious how you have thought about that, and if there are any sort of ways for you to be able to publish those interfaces from the hub or in some sort of documentation format, and then be able to consume that interface specification at the implementation side to be able to make sure that what you're writing is going to work when you actually go to push it to production.
So one of the things that I love about talking to you, Tobias, is that you just gave me such a softball. Clearly, you've read the documentation. So one of the big challenges that we run into in Salt is exactly what you're describing. We basically say, hey, here's some functions that implement this kind of pattern. Here's some plugins that implement this pattern. Just copy them and you'll be okay. Oh, by the way, you don't actually need function X. So one of the first things that I implemented inside of POP is this concept of contracts. And you can't make really pluggable software if you don't have some way to enforce interfaces. And so if we step back and look at this, contracts inside of POP allow you to say that any sort of plugin interface that exists can be enforced down to a function level. And when I say function level, I mean all the way down to function signature validation. So that when POP loads up a plugin, it's able to inspect that plugin, compare it to a contract that defines all of the necessary functions and their function signatures, so that it can come back and say, no, you haven't implemented this correctly because you aren't accepting parameter foo. Therefore, I'm just going to stack trace before I even try and run your code, which means that we're able to avoid having those situations where an improperly implemented plugin ends up blowing up on somebody long after it's been set up. And so the contract system wraps every one of the functions in every one of the plugins that are expressed on top of the hub. So what that means is that we can do load time validation, so that as soon as that plugin subsystem gets loaded, it can come back and say, these functions are good, these functions are bad, but it can also wrap the actual execution of functions. So you can kind of think of it like decorators, but since we're allowing people to create entire plugin systems, I felt really strongly that we needed to be able to make decorators transparent. so that if somebody wrote a plugin for a pop program, that they would be able to then come back and say, look, the wrapping functions just magically work for them. And this is another thing that Contracts gives you. Contracts allows you to define pre, post, and call functions, so that you can say that anybody who implements function X, before that function is executed, we're going to execute a pre-function. And in that pre-function, you can do things like input validation or even modify what your arguments and coarguments are that are being passed into that. And then the post allows you to do things like modify the return. Modifying a return allows you to do, one of my favorite things that modifying the return allows you to do is to say, well, I'm going to express this plugin subsystem as a front end to maybe an RPC or a REST interface. And so I always want that return to be a certain object, right? Well, now you don't have to put the creation of that object on your interface implementer. You can just do it inside of your contract once instead of having to instantiate your returns repeatedly as said object. Another thing that we've used this system for on the pre and the post is that we've got a central location where all of the role-based access controls are implemented. So it makes it really easy to be able to say things like, yeah, anybody who adds a function that accesses the database is going to automatically inherit an RBAC layer, so that somebody can say, yep, I've got a database interface and I'm going to use plugins to implement all of the right functions to use a different database backend. But the actual access to that database backend is still regulated by one unified RBAC system. And so in some of the projects that we've got inside of SaltStack, we've used this to implement RBAC, not only on the database layer, but also on the RPC and REST layers. And so contracts are incredibly valuable.
And another thing that you mentioned is the ability to merge these different plugins or even applications implemented using POP into larger applications for runtime or for deployment. And it seems that it would also be possible to take one of these larger applications and then decompose it into independently deployable microservices. And I'm wondering, what are some of your thoughts on the challenges that an engineer might face when designing and implementing a library for being able to take advantage of these capabilities, either in the merging or the decomposing aspect, and some of the sort of best practices around how to make sure that the plugin that you're building or the subsystem that you're implementing and defining is going to be able to work in these environments?
Now, this is an area where I need more documentation and also an area where I'm still learning. It's been really interesting to come back and implement a bunch of little projects. So I've implemented a lot of little projects using POP. Most of them originally were just to try and ferret out these sorts of ideas. You really have to look at your application through a different lens when you're creating an application that's purely pluggable. You end up looking at it and saying, well, how is my instance data going to be expressed on a hub? What are the implications of app merging? What do I need to do to make sure that my system is still really flexible and pliable, but also still simple to the point and gets the job done that I'm trying to execute? And so this falls back on an old kind of saying of mine that is, if you have a really complicated problem, the best thing to do isn't to try and just hit that problem head on, but it's to minimize the impact surface area of the problem. And then that minimized surface area becomes manageable. So instead of looking at things and saying, I want to solve memory management for every piece of software that's out there, one would come back and say, how do I make it so that it's just really easy to keep track of my memory usage? What if I made it so that it's really easy to know where the bodies are and get alerts really quickly about performance and profiling and memory issues? And so if you take that approach, then your surface area becomes small and compact. And then your application can grow through application merging. So when we look at application merging, POP currently, I don't know of any other ways of doing this yet, but we'll see. POP currently expresses two types of application merging. One is called horizontal application merging. Another is called vertical application merging. Horizontal application merging is a lot of what you were just describing. That let's say I've got 15 projects and I want to merge them all together so that all of their namespaces really just end up existing on one hub and they get to operate and function inside of one process. And so, as long as we follow the rules of not violating the namespace of your hub and making sure that your applications follow these simple rules of make subsystems that are pluggable and easily extensible, then this becomes easy. One of the big challenges, though, with horizontal application merging is the fact that each one of these applications that you merge together has merit and use in and of itself, which means it's got to have its own command line options, it's got to have its own configuration loading, and then that configuration loading needs to be expressed inside of all of these plugin subsystems. And so that's one of the reasons why POP has the configuration loading system built in. It's just recognizing that part of an application means you've got to be able to bring in configuration data. And so POP expresses a unified, hyper simplified way to bring in configuration data and make that configuration data available to your project, even when it's been merged together with lots of other projects. The other challenge that we run into is the difference between CLI invocation of a program and being able to call out that program from an app merge perspective. And so one of the little surface area issues that I've tried to minimize is to make it so that you can have all of your configuration options come in for an application, and then you can have a really, really thin function that just says, this is what it looks like if I invoke this from the CLI, and I'm still just expressing a bunch of functions that can be called from an app merge perspective. And so again, it's all about saying normally these problems are really big, but let's make the surface area really small to make it so that big gnarly problems become manageable, and that the user only needs to learn that, hey, as long as you keep a couple of these things in mind, you'll be okay, instead of having to think about ongoing, really complex problems that have to be implemented and maintained throughout a large code base, which is something that we run into in paradigm development in general. Does that answer your question?
Yes, it does. And moving on from some of the technical implications of POP into some of the more social and communications-oriented ones that we alluded to earlier, I'm curious what you anticipate as far as teams who are using this paradigm for developing their software, how that impacts the possible team structures and communication patterns that are possible, where a lot of times we have teams that are either centrally located or distributed, and so that influences whether we build monoliths or microservices. It seems that this might unlock some slightly more nuanced or evolutionary ways to design and implement team structures, and how that reflects in the software that we're building.
That's an excellent question, because when we look at building teams to develop large pieces of software, there's this book that's kind of old. I want to say, I think it was released in 1974, called The Mythical Man Month. And I love this book. I'm surprised how few people have read it nowadays. When I started out in college, it was kind of mandatory reading, right? Everybody had read The Mythical Man Month. It makes me feel old. But The Mythical Man Month was this book that was designed to be sent to managers who all of a sudden were trying to manage software engineering projects. And one of the things that it's describing is that, look, if you've got an assembly line and you want to double production for that assembly line, then you buy twice as much equipment and you hire twice as many people. And for the most part, you're able to therefore double production. And then Mythical Man Month explains that this just doesn't work for software, because you bring in more people and they have to understand this code base that you're working on so that it can be extended. And so with that in mind, I've spent a lot of time looking at how we develop software, where the innovation comes from, where the real guts and power of software comes from. And there seems to be a strong correlation between small software projects and rapid innovation, rapid prototyping, relative to large projects that can become very, very difficult to prototype on top of unless you've got strong compartmentalization. And really successful, hyper large pieces of software have strong compartmentalization, like the Linux kernel, right? Somebody can come in, they can make a driver, they can make a file system, they can get on with their lives. But the majority of software really doesn't seem to be this way. And so one of my goals with POP was to say, look, if our application is broken up into lots of small services, which is, again, similar design to microservices, then it becomes a lot easier to change what our team structure looks like as far as internal management. But I feel really strongly that this can help us with open source software as well. Because when it comes to open source software, I'm endlessly surprised how difficult it is to convey the construction of certain aspects of my code bases out into a community. So there are certain parts of Salt that I'm still the only one who's ever built anything inside of these components. Whereas if we're able to break these things up, they're more conveyable, they're more understandable, they're more consumable, how these things are actually built. And so it goes back to something I said earlier, where if you've got a code base that's a million lines of code, like Salt, and I hire an engineer and say, hey, I need you to help me maintain this thing, it takes them, I mean, sure, they're making contributions fairly quickly, but until they really are able to grasp the big architecture, it can take months of them just being in there until they're able to get that big picture. Whereas when things are pluggable, I can sit down with somebody and I can convey the whole application in, I don't know, an hour. And they're able to own it and start running in a really deep way with that component almost immediately. So for instance, I just released a piece of software built on top of POP called Heist. And I've been able to sit down with engineers, and again, literally in 45 minutes, they are able to repeat back to me the entire functional code base and pathways. And they're able to basically own that piece of software. And that is, I feel, absolutely transformative. That somebody is able to just sit down and say, yep, I'm versed on these 8, 10, 15, 4 POP projects. And it makes compartmentalization of teams a lot easier, because then you can just say who's been versed on what, who needs to be versed on something else. You can draw some Venn diagrams and you immediately understand what your actual internal software coverage looks like, right? What does your expertise look like? And then you can have rapid innovation, because when you break something up like this, Salt's test suite takes hours to run because the darn thing is so big. But I can make extensions to Item, right? The pluggable implementation of Salt's configuration runtime, very easily, because its test suite runs in 4 seconds, because it's only going to test itself. It doesn't have to go and test 18 different operating systems. And so this whole concept of rapid development changes, and proper compartmentalization and management changes, and can defeat the mythical man month, where I feel like this has the potential of creating significantly more rapid development cycles inside of companies. And that's something that personally I'm really, really excited about, and that I've got really high hopes for, that we can prototype software faster, we can get features out faster, we can write components once and not have to come back and say that I've implemented a number of these components multiple times. Even when you're using libraries, you've still got to glue this stuff together. But if you're using app merging, you can build that entire application component stack and reuse it without any modification over and over and over again. So again, it's like everything just has super glue on the side of it, instead of saying, hey, I've got a bunch of blocks and now I've got to figure out how to glue them together.
Yeah, this whole approach definitely seems like it does a good job of tackling some of the friction that occurs when we try to reuse software, where that's generally the ultimate goal of write once, reuse many times. But then, as you said, particularly with libraries or, particular applications that are intended to be incorporated into a larger whole or work alongside them, there's always some amount of rework or custom updates or glue code that needs to happen in order for things to actually be reused. And it seems that by having the entirety of the context encapsulated in this plugin subsystem, it makes it much easier and more likely that you can actually implement these aspects of your domain logic in this subsystem and then be able to reuse it across multiple code bases that need to be able to handle some of those same problem domains. So I'm definitely excited to start experimenting with that on my own. But for anybody else who has started drinking the Kool-Aid at this point, I'm wondering on the other side of things, what are some of the limitations of POP, either in the implementation or the broader paradigm, or cases where you would recommend against following this paradigm and you would recommend for something more traditional or something that people are already familiar with?
I don't feel like I've run into a whole lot of situations where I don't feel like this works really well, to be honest. And a lot of that is also that I've tried to put myself in a lot of situations of building different types of prototype software, using it to fill out the paradigm. Now, most of what I've built has been system and server side software. Most of what I've built so far has been things like management software, communication software. But when it comes to the flexibility of the platform, one of the pieces of software I wrote with it is called Umbra. Umbra is an artificial intelligence streaming system. And using plugin-oriented programming, I was able to very, very easily implement a flow programming paradigm so that I was able to do multiple data stream processes in parallel. And implementing that on top of POP was so much easier than implementing a flow system otherwise, because we're just able to use this hub and put like asynchronous queues on it, and it just works. And so I'm really hesitant to sit here today when it's so young and say XYZ just isn't gonna work well with this, because I don't know yet. And so far, everything I've tried has worked really well. Now, with that, you kind of have to think about your problem a little differently. It's not like it's terribly obvious. And some of the challenges that I've run into with people trying to build applications on top of POP is that they come back and they say, I can't imagine needing to make my application this flexible. And POP really pushes you to make really flexible software, really growth-oriented, big pieces of software where broken up into little pieces. And so if you're making something that is small that you can't possibly imagine ever getting big. So one example is one of my employees was just practicing making an application that plays cards. And I'm trying to explain, okay, I get it. You've made some classes that implement a deck of cards and poker and whatever. And I'm going, POP, from a POP perspective, you would look at it and say, okay, I want to make a plugin subsystem that is able to flexibly create any type of deck of cards, which can then be applied to any type of game that could possibly be made with cards, so that this platform could be used to run a poker game as well as like Pokemon or like Magic the Gathering or whatever. I'm trying to think of random card games. And it's not too terribly difficult to look at somebody who says, I just want to write a poker game and say, okay, you really don't need to think about your application at this level of abstraction. So I guess that's a good case of maybe this paradigm wouldn't work too well.
And for anybody who is interested in getting involved in contributing to or experimenting with and giving feedback on POP, what are some of the areas where you're particularly looking for help? And what are some of the plans that you have for the future of the POP library, either in terms of the specific implementation of it or some of the types of applications that you want to allow it to be used for?
So right now I've made and released Heist, Item, and Umbra on top of POP. And I'm currently working on another project I'm calling Takara. It's really, really young, so I don't know if it's early enough to talk about it. But from a contribution perspective, I would say that most of what I've learned about extending POP has come from building applications using the framework and the paradigm. And so if somebody wants to contribute, I would say write whatever the devil you want to write, but use POP and then come back and just ask questions like, hey, I'm trying to accomplish X. Have you run into this before? Does this merit an extension to the core platform? And then it becomes a lot easier to come back and say, yeah, that does merit an extension to the core platform. Let's take a look. Or, hey, we've solved this problem this way a lot. Does that make sense? Do you think that we need to refine how this aspect of the paradigm works? And so historically, I'm so used to Salt, where it's like, you want to contribute to Salt? There's all these modules. Just add some modules. POP itself it's a paradigm. It's kind of a different animal, and we will learn more about it by using it more. And so, if somebody ever writes a POP application, please let me know. I'm going to make a POP awesome repository so that it's easier to keep track of, hey, here's a bunch of applications that are written in POP. But beyond that, I mean, that's really the place to start with contributions. If we step back and we look at it from the perspective of some of these other projects, Item, for instance, already has a growing group of people who are building support for cloud management on top of Item, so that we can port a lot of the functionality of Salt Cloud to be more standalone, more flexible. And similarly, on top of Item, we're trying to get more people who are interested in taking it as just a language. Because again, it's basically Salt States, but Item allows you to run Salt States decoupled from being part of a big Salt ecosystem. And so a lot of what we want to do there is actually port stuff from Salt over to Item, or just allow people to write more interfaces to manage whatever they want on top of Item, whether that's an arbitrary API somewhere like a GitHub API or whatever, right? A Bamboo HR API, I don't know. So, I mean, those are some areas of contribution that are interesting. But again, the reality is make whatever you want, but try it out with POP and let me know how it goes. And so we can make this thing better.
Are there any other aspects of the POP implementation itself or the overall paradigm or some of the ways that you're using it that we didn't discuss yet that you'd like to cover before we close out the show?
We had fantastic coverage. I almost always forget contracts, and you made sure we got that too. So I think we've got pretty good coverage here.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing or contribute to some of the projects that you mentioned, I'll have you add your preferred contact information to the show notes. And so with that, I'm going to move us into the picks. And this week, I'm going to choose the show The Man in the High Castle. I just finished watching the last season of it, and it was great all the way through. So I thoroughly enjoyed that. So if you're looking for a show to watch, definitely recommend that. Not as friendly for kids, but all in all, a great story. So with that, I'll pass it to you, Thomas. Do you have any picks this week?
I've really been meaning to to watch Man in the High Castle. I saw the first 2 seasons, and it was just phenomenal. And that did just come out. So that's a really cool show. I think a new season is coming out or just came out on Tom Clancy, the Jack Ryan season on Amazon Prime. I'm really looking forward to that one.
All right. Well, thank you very much for taking the time today to join me and share your thoughts and experiences on this paradigm and library. It's definitely something that I look forward to experimenting with and seeing some of the directions that you take Salt and associated projects with. So thank you for all of your time and efforts on that, and I hope you enjoy the rest of your day.
Thanks, Tobias. It's always great to hear from you.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.